Next heading is wide band FM. We know one thing, that beta here is greater than 1. But before we go to wide band FM, yeah, आप एक ऐसी लाइन लिखिए. Wide band FM is represented in the form of Bessel function. Wide band FM is represented using Bessel function. So therefore, before we go to the wide band FM expression, a basic understanding of Bessel function is important. Okay. So you first write down the heading. Bessel. क्या होता है एक Bessel function? It is, आपने पढ़ा है ये Bessel function? नहीं पढ़ा है? No problem. It is actually, you can say, a combination of so many exponentials which are decaying with time. If you remember last time, हमने एक sinc function बनाया था, right? अब Bessel function यहाँ के केस में हम देखेंगे, we have exponentials which will be decaying with time. Okay? So कुछ वैसी टाइप की relation है, but let's see how. So the expression for Bessel function is Jn of x, the coefficient of Bessel function, 1 by 2 by minus 5 pi e raised power j x, the same variable x over here, sine of theta minus n theta. Is this expression clear? Please note it down very clearly. So 1 divided by 2 pi into n theta dot d of theta will also have the implication over here. So some of the properties of this Bessel function, so that we can understand this better, that what happens inside it. Maybe we will not go towards the derivation mathematical side as of now, because we are most likely अपने mathematics में पढ़ेंगे. जो engineering mathematics है, you might have some more. This should have been there. Anyway, so let's write properties of Bessel function. So as to get an understanding about this, है क्या इसके क्या features हम आगे use करेंगे, which features of this function we will use in FM. So just write the heading properties of Bessel function. First property is property number 1. Jn of x increases. Jn of x decreases as Jn of x decreases as n increases. मतलब जो इंटेंसिटी है या जो कोएफिशिएंट का वैल्यू है वो कम होता जाएगा जो n आगे आगे बढ़ता जाएगा. मैंने आपको अभी यहाँ पे दिखाया ना एक्सपोनेंशियल्स, या जिस तरह आइज ऑन बोर्ड प्लीज. मैंने कुछ कहा, सुना आपने? नहीं सुना? सुना आपने? नहीं सुना. राइट. सो मैंने ये कहा कि इससे पहले मैंने यहाँ पे ग्राफ दिखाया ना आपको. सिंक फंक्शन याद है आपको? सिंक फंक्शन याद है? दूसरा ऑक्सीडेटरी उसको से डीके का सामने टाइम. ठीक है. तो यहाँ पे इसका जो नेचर होगा, ये आपके पास एक्सपोनेंशियल्स होंगे, ये डीके होते जाएंगे विद टाइम. सो पॉइंट नंबर 1, Jn of x जो वैल्यू है इस कोएफिशिएंट का या एक पर्टिकुलर स्पाइक का एम्पलीट्यूड है वो कम होता जाएगा as n increases. So this is point number 1. This means, that is for your understanding, J0 of x is greater than J1 of x is greater than J2 of x, right? सबसे बड़ा कौन सा होगा? J0 of x. I mean value is the highest one. Point number 2 or property number 2 is property number 2. Write this very clearly, neat and clean. J of minus of x, that is when n is negative, is equal to minus 1 of -1 raised to power n j n. Okay. क्या निकलेगा यहाँ पे n जब इवन होगा -1 रेज पावर इवन वैल्यू -1 बस खत्म for n equal to even j of -n of x is equal to jn of x. Go dimension same. So as inverted for n is equal to even. You see in graph in बना से आकाश square. For example, when n is even, this will be same. But when n is odd, just negative. That's it. So write down this is for even. And j of -n of x equal to minus of j of n of x for odd value of n. क्या सही? बेहतरीन. You got this? Nice man. Is it done? Teachers, कोई इशू तो नहीं है अब तक इसमें? आपको क्या समझ में आया इसमें? नहीं क्या समझ नहीं आया ये बोलो बस. सब ठीक है? Anyone else? You got this point? Any confusion here? As of now, we are not deriving anything mathematically. So that might be lack of point, half point. That is okay, but you just need to see the practical significance of that because we are going to use it directly. Okay? We may not go into the deep mathematical derivation because that is definitely should be your part of Indian mathematics, and there are so many things on this. You can read or go through a book which has lessons function in it. It is very useful. Property number 3 is if you sum all these coefficients all along, जितने भी coefficients हैं, if we sum all these coefficients, this, if we sum all these coefficients and take a square of them, that is from n equal to -infinity to infinity, jn square of x, it will be equal to 1. Important point, right? Point of objective also, a point for y also. That summation of n multiplied into jn of square is equal to 1. And the last point is jn of x is always results in a real quantity. या jn of x is real, इतना भी काफी है. अब चलते हैं जनरल एक्सप्रेशन ऑफ f वाइड हेडेड. So now the heading is general expression of wide band FM. So So we know this expression already, that S of Fm of t is given as AC cos of by Fc t plus beta sine of 2 pi Fm. We know that cos of theta is actually real of E of J of theta. Okay? That is the real part. Therefore, substituting, this is, let's say this is equation second, this is equation 1. Substituting the value of cos of theta in equation 1, we have. So we are using this expression. That pretty much common sense. Therefore, the expression becomes S of Fm of t is equal to AC real of E raised to थीटा के बदले क्या है यहाँ पे? ये सारा क्या है? ये सारा क्या है? थीटा. So cos of theta is to be replaced by real of E raised to j theta. So real of E raised to j theta कितना है? ये सारा. So that is 2 pi Fct plus beta sine of 2 pi Fmt. यहाँ पे ब्रैकेट आएगा. So we have sum of 2, so I will break them into 2 exponentials, one being E is equal to j 2 by Fct dot E is equal to j beta. Can I do this? Can I do this? Yes or no? Can I do this? So in this part, E is equal to j 2 by Fmt is a continuous periodic signal with t, that is time period, equal to 1 by Fm. Am I correct? 1 by Fm होगा इसका time period. ठीक है? Therefore, E raised power j beta sine of 2 pi Fmt will generate a Fourier series given by Ft. This is the Fourier series, okay? This will result in a Fourier series or can be replaced by a Fourier series expansion given as Ft equal to summation of n going from minus infinity to infinity j n of theta. यहाँ पे हमारा बेसल फंक्शन इंट्रोड्यूस हो गया. E raised for j n 2 pi fm t. I repeat that ये जो हमारा है ये periodic continuous periodic signal है. This will result in a Fourier series. Ft is the Fourier series आप लिखिए, where Ft is the exponential Fourier series, where Ft is the exponential Fourier series, where Ft is exponential Fourier series given as Ft is equal to summation of n going from minus infinity to infinity, C of n, e raised for j n 2 by f naught t. अब फर्क क्या है? इस केस के लिए C of n का वैल्यू है j n of beta, that is it is given by the Bessel function, where Cn of t, Cn is equal to, where Cn is equal to Jn of theta. For this case, we derive it, but I have skipped the derivation for you because that will unnecessarily take us to a different direction. So this is a continuous periodic signal. We can represent this by the exponential Fourier series given by Ft, and Ft is given as summation of minus between Cn e raised for j2 by fmt. But for this case, Cn is equal to Jn of beta. Cn is the constant. Okay. Next, okay. अब आप इस चीज को सब्स्टिट्यूट कीजिए कहाँ पे? जनरल एक्सप्रेशन में. जनरल एक्सप्रेशन में पुट क्या आया देखिए, पुट दिस वैल्यू ऑफ e raised for j beta to by t in the general expression. Put this value of यहाँ पे shall I erase this? Can I erase this? Yes or no? Yes, sir. So now the expression for Band F.M is equal to AC real of A raised for j 2 by FCT dot इस एक्सपोनेंशियल के बदले अब आ गया समेशन ऑफ n गोइंग फ्रॉम माइनस इंफिनिटी टू इंफिनिटी j n ऑफ बीटा e raised for j n 2 by fm of t, which will result in AC real of summation of n going from minus infinity to infinity j n of beta into e raised for, दो एक्सपोनेंशियल है यहाँ पे, ये वाला और ये वाला, j is common, 2 pi is common, t is common, so otherwise fc plus n times fm, right? And that's what we want. We want something to modulate our frequency, or something from the fm side to change our frequency. So fc plus n times fm of t. Or else now we can do the reverse. This is one form of general expression, but maybe a more popular form would be, now we said cos of theta is equal to real of theta, right? We can do the reverse. Real of theta is equal to cos of theta. So instead of real, we'll go like cos of same thing. Summation n is equal to minus infinity to infinity jn of beta e raised for j 2 pi fc plus n times fm of t So we have our cos AC. AC cos, no change in the amplitude. The only change is in the angle or in the frequency part, which is theta. So amplitude is constant as AC. But AM के केस में AC में ही modification आती थी based on message signal. यहाँ पे आपकी frequency में change आ रही है based upon the message signal. Therefore, this is the frequency modulation. Check. N is defined to infinity. J of beta it is for this is this. So this is the final expression and a very important expression as well. Huh? So there's a slight change in this area. Change something, note down key. I've changed this expression, please note it down. This is the final expression for your wide band. So frequency spectrum of wide band FM. अब किससे मिलेगा इसका frequency spectrum? जरा मुझे बताइए. Wide band FM का spectrum किससे निकलेगा? Bessel function की properties से ही हम इसका spectrum निकाल सकते हैं. So आप लिखिए यही एक्सप्रेशन लिखिए फिर से that क्योंकि स्पेक्ट्रम जो है आपके जनरल एक्सप्रेशन से ही निकलता है ना. स्पेक्ट्रम ऑफ वाइड बैंड एफएम टाइम क्या है? 9:45. So first write this expression. Step number 1 is write this expression again, and then step number 2 is S of wide band FM is given as AC, because what I will do now is, eyes on board, what I will do now is I will put values of n that will result in different components of the Bessel function. So when I put n equal to 0, that will result in J0 of beta cos of 2 pi. n is 0, fm वाला part खत्म हो गया. 2 pi fc of t. Am I correct? Do you follow me? What? I don't think so. Very good. So n is 0, that's why this, I repeat, I have taken this expression as a general expression. Now what I am doing is that I have put values of n. We started with n equal to 0, then n equal to 1 and so on. So I have to get the expanded form of this expression. Because once we get the expanded form of this expression, okay. Once we get the expanded form of this expression, we will see different spectral components together. Okay? So when substitute n is equal to 0, while n is equal to 0, we get J0 of beta cos of 2 by fc plus n is 0. n is 0, fm will vanish. So 2 by fct is the only part. Now let's put n equal to 1. So by substituting n equal to 1 in this summation, the next component will be ACJ1 of beta cos of 2 pi fc plus fm of t. Okay. Now let's put n equal to -1. So AC j of -1 of beta into cos of 2 pi fc minus fm. Can you see something? Upper side, lower side, and something is happening. So plus AC J2 of beta. Can you complete this please? Put n is equal to 2 in the summation and get me the component. Put n equal to 2 and then n equal to -2. I want to see what you will do. So it is AC J2 of beta cos of FC plus 2 times FM of T, and if I continue plus AC J of minus 2 of beta cos of 2 by FC minus 2 times FM of T. क्या प्लस नहीं आएगा, माइनस ही आएगा ना. ओके so can we draw the spectrum out of this? Yes or no? Can we draw the spectrum considering the positive side spectrum only? Let's say this is 0. At some point FC, at some point FC plus FM, I will have AC J1 of beta by 2. At some point FC minus FM, I will have AC J minus 1 of beta by 2. So we know that as n increases, the coefficient of Bessel function decreases. So इसकी intensity इससे भी कम होगी, which will be now AC J2 of beta by 2, and यहाँ से AC J minus 2 of beta by 2. आ जाए इधर. यहाँ पे ये FC पे है, ये FC प्लस FM पे है, FC माइनस. जरा यहाँ पे फ्रीक्वेंसी क्या आ जाओ जवाब. You can write the left hand side. Very nice. So add, now if we just modify the same thing again, we know by property of Bessel function, you can just redraw this one, you can just redraw this one, you can just redraw this one, but for odd values of n, it will go like this. For odd values of n, your value will be minus of AC J1 of beta by 2. So now you have a kind of uniformity that you have only J1 of beta from this side and J1 of beta from that side also. For even value, it will be same as it is. So it is AC J2 of beta by 2. Now this minus 2 gets converted to J2. Is that, are you able to identify that? Are you able to identify that? Have you written it down? Okay, I am coming to see that. So, by the way, can you tell me which is the upper side band? Which is the upper side band for this? This is FC. Which is upper side band? Just stand up please and say louder. Okay, sit down but say loud. This is the, what about this? What is this? This is lower sideband or upper sideband? Louder. Right. So that means we have multiple upper sidebands and multiple lower sidebands. Therefore, this is first order. You just name this first order upper sideband. So this will be second order upper sideband. Likewise, for this case, first order lower sideband. Or you can just go to this also. This is the first order lower sideband and this one second order lower sideband. Is that clear? Picture? Simple सुना? कोई कॉम्प्लेक्स चीज नहीं, नॉर्मल है, बस ध्यान देना और समझ आ रहा है। क्या बीच वाला है ना हमारा कैरियर कंपोनेंट, बोथ साइड का, the middle one is the carrier component and it is obviously even if you see any other spectrum, बीच पे कैरियर, दाएं बाएं हमारे साइड बैंड। ठीक है जी, हो गया। Okay, now next heading is wide bandwidth of wide band FM. By the way, just to tell you, this will continue to infinity. Okay, this will continue because हमने यहाँ पे एक्सप्रेशन लिखा, मैंने यहाँ पे डॉट 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 बनाया. That means this will continue to infinity. So, what can be the bandwidth of this wide band FM? Yes, what is the general expression for bandwidth? Come on! This is not right. Disappointing. Yeah, ये नहीं होता है. This is not to be done. I need you to be slightly more active. You are not what you actually have. You are much more better than this. Okay, आप बताइए. You are at the right extreme corner. आप बताइए. What is the general expression for bandwidth? Any idea? Yes or no? So भैया सीधे बैठो आप सीधे बैठो हाँ या डिस्टेंस से जाओ आप बताइए हाँ आप बताइए मगर वो चुप कर रहा तू ये प्रॉब्लम है तू गुस्सा दोल आप बताइए राइट भाई साहब हम इसको नहीं हम ऐसे जनरल एक्सप्रेशन दिस शुड बी these general expressions, you know that. That's why I'm asking any question to someone because I know the person knows the answer. You know this answer. But just that you're not retrieving it. I don't know why. That's why I'm asking because I know that you know the answer. Anyways, but in this case, the highest positive frequency will be what? Infinity. So the bandwidth of such case of wide band FM will be infinity. So, bandwidth of wide band FM is equal to infinity. For wide band FM, so notice making note for wide band FM, what is the time? 10:05. For wide band FM strength of higher order side bands, बस सुन लीजिए इसको लिखिए मत. For wide band FM, the strength of side bands goes on decreasing and finally becomes zero. Okay? लेकिन कहाँ पे zero हो जाएगी infinity? This is one point. For wide band FM, lower order side bands are said to be significant. For wide band FM, lower order side bands, lower order, छोटे पहले वाले, are said to be significant side bands. Do you remember? Do you remember what is a significant side band? Yes or no? Just take go to your notes. What do you mean by significant sidebands? What do you mean by significant frequencies? So I say that the lower order sidebands are the significant sidebands, whereas the higher order sidebands are insignificant. I think that has a message for you and you can understand what that means. Last time किसी का पेन रह गया था। Ask yourself